I thought you told me.
Okay, so today we are going to start chapter 5. Listen here. Do you have any question? Anything? Okay, so we are going to start chapter 5. We are going to talk about polynomial, and now I will explain about polynomial, and then we have lots of operation on this polynomial. So polynomials. This means many. This means name, and in mathematics, let's say terms. So polynomial is a combination of some terms, either subtraction, addition, combination of these terms. So what are the terms? We already know what is variable, right? Variable, we show variable with x, y, z, correct? These are the variables. And then sometimes these variables can have coefficient. For example, 2x, correct? 2 is the coefficient of variable. And sometimes this variable can have exponent, correct? Like y squared. And then let's say sometimes we have like this multiplication of two variables and the coefficient. So each of these you see here is a term. If I have plus, subtract, some of these, mathematical notation between them, it means we have combination of terms. How many terms we have? 3 of them. So we call this polynomial, okay? So there's something about polynomial. First of all, this one is constant, correct? 2 is a constant. 2 is also a term. And I remember I talked about this. For example, this 2 here could have a variable. How? The variable, for example, imagine an x with the power 0, right? Because you know x power 0 is always equal to 1, right? So that's why you didn't see anything here, because 2 multiplied 1 is 2, right? So any constant also can be a term because it could have a variable. So now there are some properties for this polynomial and these terms. So if you have combination of terms and you're going to call it polynomial, you should be careful. These terms, for example, let's talk about this. This term has an exponent here for this variable, right? This one also has an exponent for variable, correct? So 2, 1. The numbers you see here, or if you have an x here, 0. The numbers you see here are never negative numbers. They have to be all the numbers from 0 to infinity, all the integers. Okay? All the integers. No negative and no fraction.
What are those lines you put after that?
No, just I wanted to emphasize on this exponent.
Oh.
That's it.
Sorry.
Okay? So the first rule about polynomial, if you want to call anything polynomial and it's a combination of terms, those terms, their exponent cannot have a negative number. Okay? And also cannot have a fraction. So overall we can say they are all positive integer. Or what was whole number? Whole numbers start from 0, right? 0, 1, 2, 3. Do you remember? I don't think you remember. Do you remember?
Well, wait.
Natural number, whole number. We talked about this, integer, all of this, right? We talked about this. So all the exponents should be all the numbers from 0 to infinity. All of them are positive integer, no fraction, no decimal term, no decimal exponent. Okay, so as you see, it says the exponent should be 0 to infinity, all the positive integer. It says no division by variable. Why? Because let's say I'm dividing each of these terms by x power 3. So when it says division, it means something like this. So divide this by x power 3. You have x power 2, x power 3.
You'll get a negative x.
Negative exponent for this x. Correct? So that's the reason. So the first condition and the second are exact same, because if you divide these terms by any variables, it may cause either a like negative integer or a decimal integer, something like that. So we don't want that. It says it cannot have an infinite number of terms. It means if you have a polynomial, it cannot be like that. Dot, dot, dot. It cannot be like that. You should know how many terms you have. So this dots means it's going to continue, correct? And there are many terms and you don't know what are those. So we don't want this. We want everything to be clear for us, okay? So these are the conditions. And there are different types of polynomials. Either a polynomial have just one term, it can have just two terms, it can have three terms. The most famous one is one term, two terms, three terms, okay? The rest will be still polynomial, higher degree polynomial, higher term polynomial. So if I have, for example, just one term for my polynomial, let's say just this. This is just one term, okay? We call this monomial. So what is this? This is a polynomial, and because it has just one term, we call it monomial, right?
Mono means one.
Mm-hmm.
I will not history.
Monomial.
Mono.
So what about this one? This is just one term, right?
Wait, 5y?
10. No, just 10.
Oh, okay.
10 is just one term, right? So what we call this polynomial?
Monomial.
Yes, because if we have just one term, right? That's why. So if you have just one constant, still that is a polynomial, but we call that monomial because there's just one term. So just one term. Now, let's say we have 5y power 3 plus 2y. How many terms?
2.
So we call this
A binomial.
binomial. Okay? So what are these? These are different types of polynomial. Okay? Then let's say we have 15 x squared plus 8x plus 8. How many terms we have?
3, so it's a trinomial.
We call that trinomial. So if I ask you what is the type of polynomial, you should see how many terms you have. Then if it is just one term, you will call that monomial. If there are two terms, you call that binomial. If you have three terms, you call that trinomial. Okay? So the rest, generally you can just call them polynomial. So this was the type of polynomial. Now I want to talk about degree of terms. So degree of terms are the exponent of the variable in that term. So let's say this is the term, correct? So what is the exponent of variable in this term?
2.
So the degree of this term is
2.
2. So degree of this term So what is the degree of this term?
1. Oh no, that one. Yeah, 1.
The degree of this term is 1, right?
Yes.
So this is degree of 0. And then imagine if I have 5x squared y. So now you think about this.
Wait, what did you just write?
This one.
Oh, okay.
Yes. How? 3. How? 2 here and 1
there.
here.
So
You will add them together. That would be the degree of that term. So if you have more than one variable, you will add the exponent. Okay?
So that would be
The degree.
the degree would be.
Do you have any questions so far? Yes.
Are you supposed to count the exponent for the constant too? Can you do that?
So here,
Yeah, the constant.
so constant doesn't have, no.
So,
I know what to say. So 5 power 1, no, we are just talking about the variables in that term. Just the exponent of variables. Okay? Good question. Yeah, just exponent of variables. So now what is the degree here?
2.
I. Is that correct? So we just look at the exponent of x and the degree is 2, right? Degree of this one is
4.
this one,
Oh, that one. Just
3, right? This is 3. This one,
1.
1. This one,
2. 1.
okay. So now we just went through each term. So now you know how to calculate degree of, for example, this term, this term, this term. So now polynomial has a degree too.
Oh, okay. Do regular numbers have a degree to them, like 8? Like it doesn't.
So he just asked that, yeah. He said, shall we calculate the degree of 5, which is maybe 1? He said, no, just look at the variables.
So for that bottom one, 8 just wouldn't.
So this one I said, let's say x is a variable, imaginary variable, which has exponent 0, right? So like here I said the degree is 0, right? So that's why.
So it just wouldn't have it.
Nothing, yeah.
Okay.
So mainly the purpose of knowing the degree of each term is to calculate the degree of polynomial. So this is a polynomial, right? So degree of polynomial will be highest degree of term. Like between these terms, which one has the highest degree? The first one, right? So we say degree of this polynomial is 2, because the highest degree for terms is 2. So whenever I ask you what is the degree of polynomial, you should see which term has the highest exponent, highest degree. And then you will say, okay, degree of polynomial is the degree of highest degree of terms. Okay? So what is the degree of polynomial here? Look at this.
4. It's 4.
So what I said, 3, correct. So
Wait,
what I said calculate degree of each term, right?
Oh.
Then the highest degree of terms will be the degree of polynomial, right? So what was the degree here? 1, correct? What is the degree here?
3.
So which one is highest?
3.
3, right? So that would be the degree of polynomial.
Wait. Can you repeat that thing you just said? The highest degree of what?
So let's look at the example. The highest degree of terms. Highest degree of terms. So let's look at this. So we have 5x power 3y plus 3y 3xy plus 5y 4, let me say 5, plus 2. So if I ask you what is the degree of this polynomial, the first step is to calculate each of
The terms.
degree of each of terms, right?
Yeah.
And then you will pick the
Highest one.
highest, which is
5xy. Oh no, 5.
5.
I'm just kidding. 5.
what is the degree? What is the degree?
Five.
Degree will be just one number, 5,
5.
right? This one. See, I'm scared to do this because you told me because you told me what is that. So now I don't want to read.
No. It's
Okay, so
5.
let's see. What is the degree of this term? 4,
4.
right?
Yes.
What is the degree of this term? 2, right?
Oh wait. Oh yeah.
1
'cause
plus 1.
Okay.
3 plus 1. What is the degree of this one? 5. What is the degree of this one? 0. Okay? Because I said, imagine there was an x here with the exponent 0, right? And we are just mentioning this. Correct? So now between 0, 5, 2, 4, we are choosing highest, and this will be the degree of polynomial. Okay?
Yes.
So more example. Okay. Not that long. One more. So 8. 5 plus 3 y plus what's going on? Let's 4x power 2y power 3. So okay, so how many terms we have here? How many terms we have?
1, 2, 3.
3, right?
Yes.
So what we call this? What is the type of polynomial?
Trinomial.
Is that correct?
Yes.
See.
Trinomial, right? So I could ask 2 questions then. Type of polynomial, you would count to see how many terms we have, right? And then you will say trinomial because we have 3 terms, right? And then other question, what is the degree of polynomial? So to find that, you should calculate degree of each term and then choose the highest as a degree of polynomial. Yes.
What if there's 2 of them that are the highest, like 5, and then another 5? I'm sorry.
Here,
That's-
this
I
question.
just saw that. I'm sorry.
So now you tell me. This is a question for you. So, what is the degree of polynomial?
5.
Correct?
Yeah.
Is that correct?
Yes.
Because we have 5, another 5, and 4. So I said choose the highest one, and obviously you see that the highest is 5, but doesn't matter if you have many of these 5s.
So it would just be 5. Even if there's like two.
Yes.
Fives.
Correct? Yes.
What if you have what if all your terms have the same degrees? Because there's no highest.
So it will be, the degree will be that number, which is maybe repeating 5, 6 times, 8 times, right? So your question is like this. Let's say I have 2x plus 5y plus 3x, right? So first of all, if we want to do operation on this, what we do?
Just give the exponents.
We have two similar terms here, right? We have to combine them, correct?
Terms.
So what happens? We have how many x you have? 5. Plus 5y. So what is the degree of this polynomial? 1.
1. Oh,
Right?
yeah, because both of them are 1.
1.
You just explained it in the past equation. So why are you explaining it again?
They asked question. You have to.
Well, you explained it the first time. I don't understand the second.
Yeah, but so these concepts are maybe new for some student, and we have to repeat that over and over until we get it. So questions are helping us actually to understand everything much better, and it will, make you to memorize everything. I mean, doesn't matter if it is previous question or not, doesn't matter at all. Okay, so any other question? Question? So, is this clear? We have degree of 1, right?
Yes.
Even though we have similar degrees. So, now, these are the easiest part of polynomial.
Oh my god.
We have operation on polynomial. Mostly in these chapters, there are formula that you should memorize. Or, you don't have to memorize, you have the card always with you, right? Especially for the exam. So no stress of memorizing anything. But we start with the easiest operation, like adding polynomial. We already did something here, right? We combined the like terms. Did you see that? We just added the like terms and we combined them. But let's go through them. Okay, so there are two parentheses here. The first one is a polynomial, right? How many terms we have?
3.
3, right? So what is the type of polynomial?
Trinomial.
Is that correct?
Yes.
All of you? So what is the type of polynomial for the second one?
A trinomial 2.
Is that correct? So now, because we have 3 terms for the second parenthesis. So we want to combine them. So we had a kind of hint here. We look at the like terms, okay? And let me write it down here. So before we combine them, I have another question also. Okay, write it down and then I will ask you. So, what is the degree of this polynomial here?
2.
Correct?
Yeah.
Yes.
Is that 2?
Yes.
What is the degree of this polynomial?
2.
Right? So luckily, all the variables are just x. We don't have y, z, or anything like that. Okay? So we are going to just use one variable when we are doing operation from now on. We use just one variable. Either you will see all this x here, or all y, or any other letters. Okay? So now we should look at the like terms. So let's say remove the parenthesis y, because this positive will apply to each of them and nothing will change, right? So let's remove this because it will not change anything. And now we should look at the like terms. So what are the like terms here?
5x and 3x.
5x and?
Negative 3x.
Where's 5x? I don't see 5x.
5x squared.
5x squared,
Sorry.
correct? 5x squared and?
Negative 3x.
Negative 3x squared. So can I remove this? Because it will not have effect, right? All the sign will stay the same. So these are the like terms. Do you know why? All of you? So power of x is 2, the same as this one. Both of them have the same power. So that's why they are like term. So this one has power 1, right? This one also has power 1. So that's why these two are like terms. And then this one is constant. These are the like terms too. Correct? So now combine them. We have 5x squared minus 3x squared, which is 2x squared, negative 3x power 1, negative 7x power 1. We have negative
4x to the power, just negative 4x. Oh yeah, negative 10x.
negative 10x, right? And then we have negative 8 and positive 9, which is positive 1. That's it.
And then that would be our answer.
That would be the answer. So why we don't continue? Because we don't have any like terms, right, to combine. That's why. So now we have negative 5x squared minus 19x plus 15. And then here the parenthesis, are you right? Yeah. Here the parenthesis is important because it tells us this negative sign belongs to each of these terms inside the parenthesis. So you should apply it to each of terms. So still in your exam, I saw many of us students didn't apply the negative sign, didn't apply the coefficient here to each term. I saw that. So be careful. This belongs to each of these. So I'm going to remove this because it doesn't change anything, because we don't have negative sign outside. So 5x squared minus 19x plus 15, but I'm going to apply this negative number, a negative sign here. So this negative was negative 1 actually. Okay, you are multiplying negative 1 to each of these terms. So it will be negative 3x squared. Negative multiplying negative is positive 4x minus, because negative multiplied is positive 13 is 13.
So you're like distributing that negative to the other.
Yes. Correct? And then like terms.
Negative, oh wait, yeah, negative 5x squared.
Like
And
terms.
negative 3x squared.
And then
And negative 19.
terms. Correct? So those have the same color, they are like terms. If you compare them, you will understand why they are like terms. So we have negative 5 x squared, negative 3x squared, negative 8 x squared, negative 19x, and positive 4x is
Negative
15x. And then we have two constants, 15 and negative 13, which is
2. 20. Oh, just 2.
20.
20. I was adding 19 and 13.
See, these are all the mistakes. You know, mistakes are good once, 2 times, 3 times. But if you repeat that,
Also, you don't subtract or add any the exponents. Ever.
No.
You don't do that. Okay. I'm just
because we are just adding.
Uh-huh.
Later you will see if you are multiplying, yeah, we have to add the exponent. But now we are just adding, subtracting polynomials. So, let's go back before I start explaining about multiplication. Let's look at this. So, a standard form of polynomial. So now this was your result, correct? This is the result here. So a standard form says order all of the terms in this way. What? So the highest degree first, then the next one, and the lowest one. If you have many terms, you have to order them, correct? In a decreasing way. All the exponents should decrease to the right side, from left side to the right side. And then this one is the leading term. And then this coefficient here is the leading coefficient. So these are something we will talk about during this class, and then you will remember as time passes. So this coefficient, because it belongs to the highest degree in this polynomial, will be the leading coefficient, and then this is the leading term. Okay? So now imagine we have this polynomial. So I want to name it like, so this stands for polynomial, and this is the variable that we are working on. Because in this polynomial, this is the only variable you see, right? So we can show it like this. If I say, what is p of 2? You will say, okay, this should be x, correct?
Yes.
So instead of x, you are seeing 2. So what that means in that polynomial, you should replace 2 by each of these. Replace x by 2 or 2 by 8. How you say it? So instead of each x, we will say 2. So in that polynomial, we have 2 power 2, right? Minus 10, 2, plus 1. So instead of x, we put 2. What we are doing, we are evaluating. Evaluating for 2. Okay, so any numbers, like I can find the polynomial at 0. So instead of this, we put 0. So you're still not done with this one. You should multiply, calculate all of these, and evaluate this. So it will be 4. 2 multiply 4 plus minus 20 plus 1, which is 5. Right? So this polynomial at 2 is equal to 5 because you replace that 2 and you evaluated that and you got 5.
Wait a minute. 2 times 2. Would it be like 4 squared or something?
Because what did you do? Parentheses?
Yeah, parentheses and then just keep that exponent.
No, exponent first, then parentheses.
Exponent for
Parentheses?
Wait, wait. Walk through that again.
Am I right? Am I?
Well, you wouldn't.
Oh! I saw it. Did you see it? So because I didn't put parentheses, I thought this is 24, right? But it's 8.
2 times 2 is 4. 4 squared is 16.
So now you get that. Now I get that.
Wait.
Why wait? We understood what's going on.
No.
Isn't that? Yeah.
Wait, what do you mean?
Always
What do
exponent,
you mean?
right? We had this in chapter 1. We talked about the operation, order of operation. First exponent, then multiplication, right? First exponent and radical, then multiplication and division, right?
Wait, what do you mean do the exponent first? I don't know.
Because 2 power 2 is 4. You should calculate that first, right?
Oh, and then 2 times 4 is. Oh.
That was actually easy. You could
I'm
see that.
sorry. I freaked myself out. Okay.
So 8 minus 20 plus 1 is equal to. So what was that? Negative 20 plus 9. The negative 11.
Minus 20 plus 1.
11. So don't do this kind of mistake. I didn't put parentheses, so I thought it's 24. Okay, so we wanted to calculate for 0. Let's see. So 2 multiply 0 power 2 minus 10 multiply 0 plus 1 is equal to? 1. You're laughing today a lot. So, any question? Do you have any question? No? Okay, so let's see what we have. Shall we review the degree of polynomial and terms or this kind of things more or not? How many of you wants to review the? Two? Probably by end of lecture if you have more time, because the rest are not written there. They're just 2 against the rest. So after we are done with this, we will go back and see if we remember everything. So don't forget a standard form of polynomial. So you should organize the polynomial from the maximum degree of term to the minimum degree of term. So now we are going to multiply 2. What is this? What is the type of this polynomial? Is that? This parenthesis is binomial, right? And what is this parenthesis? Singular. What is this type? What is the type of? This is 7x minus 3. So how come 5x plus 2 was binomial and
They're both binomials.
both of them are binomials, right? How come that one was binomial and then this one is wait. Really?
You took my thing. Wait.
No, I repeated you actually.
Yeah, that's what I said. Well, that's what I tried to say.
Okay. Try to pay attention because from here it will be difficult. Okay? No talk, no laugh, just listen. Okay? So we are going to multiply 2 binomials. Correct? 2 binomials. So we have 5x plus 2, 7x minus 3. So how many of you know about FOIL?
Oh, I've heard of it. But I like the box method much better.
How many of you? All of you almost. So
Box method's easy.
full says, if you have two terms here, see, look at this. This is a multiplication. We already talked about addition and subtraction, right? Between two parentheses, we had plus or negative sign. These are totally different. This is multiplication. This one multiplies to this one. So, full says, first multiply the first terms. So this is the first term, this is the first term. Correct? So you are multiplying 5x to 7x. This is the first terms. Multiplication of the first terms. Then FOIL. O. O means outer. So this one and this one, right? Because these are far from each other and they are out, right? So you are going to multiply these two the second step. It will be 5x multiply negative 3. So if you look, I am adding all these steps, right? But it depends. If I have, for example, negative sign here, so it becomes negative, right? So keep all the parentheses, so at the end you can, change them. And then FOIL. I is the third one, inner. So this one, let's show you the difference. Like this. Okay, that was like this. And this one, right? So, inner 2 multiply 7x. Follow this and then I will answer all the questions.
Okay.
2 multiply 7x, right? These two were the closest together and these are the inner. So the last one is last, right? Last term, which is this one, multiplies to this one. So this one multiplies to this one. So this was first multiply to the first. Then outers, inners, last multiplies to last. Correct? Do you have any question? So now we just simply multiply them. 5x multiplies 7x.
35x squared.
X squared, exactly. Correct? So 5 multiplies 7 is 35. And then x power 1 multiply x power 1, it gives us x power 2. Do you know this, all of you? Okay, good.
Can you only multiply like terms, or could you?
No, we don't care if they are like term or not when we are multiplying. When we are combining them, adding, subtracting, we should pay attention to like terms, correct?
Yes.
Because you just combine the like terms. But if you are multiplying,
It
doesn't matter. So 35, what you said, x squared plus 5 multiplied negative 3 is negative 15
Negative
X.
15x.
plus
14
14x
minus 6. And then you combine the middle one.
exactly. After this, you should always look for the like term because now here we are adding them or subtracting them, correct? So we have 35 x power 2 negative 15x and 14x is negative 1x, or we can just write down
X.
Oh yeah, x.
x. And then we have done.
And then that would be the answer.
Yes.
So make the exponent.
So at the end, you always should pay attention to the like terms because now we are dealing with combining them, right? So what we did, we multiplied 2 binomial, correct? This one also, another example. let's do this. But let's be more kind of fast. Okay, you do that on your own.
Oh, shizzle.
Okay, 2x minus 3. And I'm going to multiply first. And then right? Oh, I did last. So, no, I didn't do last. So this is the last one. So negative 8 multiplying negative 8. Am I right? Right? What else?
You can't.
We cannot. You cannot combine it. No like terms, okay?
Hey, I was doing it correctly though. Like putting the problem out right. So we're good.
Do you have any question? So all of you agree that we cannot do anything more, right? Because there's not any like terms. Correct? So, well, those binomials you saw, they were all different, right? This parenthesis had different kind of, terms. This parenthesis had different kind of terms. So, if you see some like terms in the first parenthesis, and you have a binomial in here, and then you have another binomial here, and then you have negative sign between these two, positive sign between these two, and then let's say this like term was 2x, and then all of a sudden this like term is, this one is exact same as that one, and then you have same terms in both parentheses, and the only difference is just negative and positives, right? You can use FOIL. I mean, definitely the answer will be correct because you are multiplying, correct? But there is an easiest way to solve this using just formula. If you see that the terms are exactly same, and you have binomial here. So first of all, both of them should be binomial. Second, both terms should be exact same, right?
Yes.
Then here, either should, whatever you have, you should have opposite on in the other parentheses. So either positive here, negative here, or negative here, positive here. Doesn't matter. So just these two signs should be opposite. So in that situation, what we do, we say, here is the first term, power 2, minus, here is the second term, power 2. That will be our answer. Just continue solving this. So what is this? 2x power 2 means 2 power 2 multiply x power 2, right? Which is 4x squared. So let me write it down. 2 power 2, x power 2, minus 5 power 2. Am I right? 4x power 2 minus 25. Correct? That would be the answer. If you use FOIL also, you will reach this part. Why? Because you are going to cancel two like terms in the middle, and then you will get the same answer. So let me show this and then. Look, if we have, for example, A is a term, B is a term, and A is exact same as that one, A in other parentheses. So both terms are similar. So you said, let's use FOIL. So we have A squared plus AB minus B squared. If you apply, you will have something like this. And the two middle term will cancel because they are like terms, and their sign is just opposite. And then you will finally get A squared minus B squared, which is this one. A squared minus B squared. So now this is the formula. So for this chapter, you should have a whole page, empty page. And then whenever I'm telling you, okay, this is the formula, write it down in your formula page. So you don't have to go back to all the notes when you are solving homework or quiz. So one whole page as a formula page for this chapter, okay? So this will be the first formula we are using. A minus B multiplies to A plus B is equal to A squared minus B squared. Be careful with the sign. This is negative sign. If you change it to positive, everything will be wrong. Okay? So this is the first formula we are going to use in this chapter and learn in this chapter.
Could we simplify that one more?
Well, how you want to?
Well, we couldn't you combine 14x cubed minus 21x squared?
No, we can't.
And what you will get?
Because you can't subtract the exponents.
Yes, because they are not like terms, correct? Are these like terms?
They have to have the same.
Same.
To have like terms.
To
Okay.
be a like terms, yeah.
So that would just be the answer?
Just leave it like that.
Or you would just leave it?
Correct? Okay, so the next one, let's use this again. So we have 7x minus 2y multiplies to 7x plus 2y. So these both parentheses are binomial, correct?
Yes.
And then the only difference between these two is negative sign, positive sign, right? So use the formula I gave you. Use it, write it down.
Yeah, I do, right here, see? It's right there.
I don't want formula. I want you to use formula.
I know, that's what I'm saying. That's what I'm doing.
Solve it.
Okay. Yes, ma'am.
Solve it. Okay?
Okay. Yes, ma'am.
So most of you already solved it, huh? So, what power 2? 7x power 2, 2y equal to 49 x squared minus
4y squared.
Okay. This is the answer. Okay. Do you have any question? Yes.
What if the first term is a negative?
Okay, let's do that.
Like negative 7x, negative 2y.
And then this should be negative 7x, right?
No, like just the first term is negative.
Then they're not the same.
They are not the same then.
Oh, I mean,
Right?
Yeah, like how about the first and the second term are negative, like 7x is negative and 7x is negative 2.
Let's do that. Let's see what exactly you want. So are you good with that?
Yeah.
Sure? Okay, so let's clean this. And okay, tell me. What you said, negative what?
Negative 7x. Just the same thing, but just 7 was negative.
It would be negative 7x squared, right? You can't have a negative exponent. Or like a negative coefficient.
I can make it so easy, but I need the next formula if I want to do that. Because, let's see. The first parenthesis, I can bring out the negative sign, right? Because it's a common factor. Because imagine it was a negative 1 multiplied 7x, negative 1 multiplied 2y, correct? So that negative 1 would be a same factor, correct? Common factor. So bring out negative 1, so what remains here? 7x plus 2y. Am I right? You never saw that? Can't we do that? Don't you think so? We can do that, right? Am I right? So I brought out the negative sign, which is a common factor, and write down positive 7x, positive 2y. Because multiply this again, you will have the same thing as the first parenthesis, right? So you can do this. Then you have multiply to 7x plus 2y, right? So now you have negative 1 multiply the first binomial, the second binomial, which are exact same, right? So if you have a multiplies to a, what you will say? What is the answer?
A squared.
Right? Do you accept this? So what if you have negative a multiply a?
Negative a squared.
Right? Negative a squared. So what we have here? Negative parenthesis square. Negative something a square. Because this something is exact same as this one, right? So imagine this was a, this was a. So you have negative 7x plus 2y, right? Do you accept this? Sure? Okay, so now I will show you the other formulas that we are going to learn in this chapter. Then we can continue this. Okay? So I couldn't use the same method, right? I just changed it to be able to use the second formula and third formula that I'm teaching you now. So what are those? So keep this. We are going to continue, okay? We are going to continue and solve this. So, if I have a plus b power 2, or maybe a minus b power 2. So what was this? This was a plus b multiplies to same thing, right?
Yes.
And then this was a minus b multiplies to exact same thing. So the sign are the same. So previous formula that I showed you, the sign were different, right? But these are exactly same. So now, a squared plus
B squared.
2 times ab plus, now we have the b squared.
Why did you put 2 times AB?
That's the formula.
Oh.
So if you multiply this by FOIL, you will see, you will remain with 2AB plus 2AB. Yes, I will write it down there, and you should write it down in your formula page. Okay? So what happens to this one?
A squared minus 2AB
Yes.
minus B squared?
No.
Or just plus?
So do you see that? So which one of this formula I'm going to use here?
You're gonna use the second one?
Top one.
The top one?
Because the sign between these two terms are positive, right? Right? Okay, so do you see this or not? So let me write down this formula. So A minus B power 2, let's just start with plus. So A squared plus 2AB plus B squared. A minus B power 2 is equal to A squared minus 2. AB minus plus B squared. So we have three formulas now. Okay? So now we are going to continue this using the top formula, right? This one using the top formula. Why? Because this is A, this is B, right? So the negative sign here is going to stay same. Keep it here, but we have a parenthesis here. Now I'm going to, in this parenthesis, I'm going to write down A squared plus 2AB plus B squared, right? Using the formula. So, A squared is 7x power 2. Am I right?
Yes.
Plus 2 times. The first term is 7x. Right? Multiplies B. B is the second term, which is 2y, right? What is the B? 2y, B squared. So now we should calculate everything inside this parenthesis, and then we have a negative sign outside the parenthesis, which should be
Positive.
distributed to each of these terms.
Yes.
Okay? So let's continue. What is 7x squared? You already know, huh? 49x squared plus 2 times 7 multiply to 2. So it will be 2 multiply 7, right? You're multiplying all the coefficients. Am I right?
Wait a minute.
2 multiply 7 multiply 2.
Oh.
First, you will
14
take care of all the coefficients.
14 times 2 is 28.
Yes. Correct?
Would you put 28xy?
20. A, X, Y. So because this one says X multiplies to Y, and we already had X multiply Y. That's why we put them together, and this is a multiplication between them, right? Plus, we have 4 Y squared. Which one you're wanting from? Doesn't matter, you know, because so these are two variables, x and y, correct? We could write down 4y squared plus this one and then this one. Why? Because we are considering y as a leading coefficient, this one as a leading term. Or we can just keep it like that, doesn't matter.
So could you combine?
No,
You couldn't combine anything.
no. Can we combine anything?
Oh no.
Do you see that? Oh, good. So what should I do now? Negative to each of these terms, right? So I have negative 49x squared minus 28xy minus 4y squared. So we solved it, right? Okay, so as I said, I need a whole page with all the formula we are going to learn this chapter. So as soon as I said, let's go back to the formula sheet, you should bring all this formula that I'm teaching you, okay? And then for exam, it will be so easy for you to just, go back to this formula sheet and write down everything you learned, right? Do you have any question? So we are going to continue with the operation on polynomial next time, Monday. And those who were late and didn't get their exam, so I just returned back the exam for 5 minutes so you can check it. Just come here so I